The triangle midsegment theorem. Our objective is to use properties of triangle midsegments. Why learn this? You can use triangle midsegments to make indirect measurements of distances, such as the distance across the volcano. Let's look at some vocabulary first. The midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. So if you look at the diagram below, midsegments would be like XY, YZ, and XZ because they connect the midpoints of each of the sides. So basically it makes another smaller triangle, which would be the midsegment triangle. Examining midsegments in the coordinate plane. So in triangle GHJ, show that midsegment KL is parallel to GJ, and that KL is in fact half of the length of GJ. So let's first find the coordinates of K and L. So we want the middle of HG and then the middle of HJ. So our middle, so K would be negative 1, or so 2, 3, 4, 5, 6. So we have negative 6, 2 for K. And then for L, we're going to have negative 2, 4. So those are our coordinates for K and L. And now we want to compare the slopes. So the slope of KL is going to be up 1, 2 over 1, 2, 3, 4. So 2 over 4, which is 1/2. And then we want the slope of GJ, which is up 1, 2, 3, 4, and over 7, 8. Which is also 1/2. So therefore, they have the same slopes. So we know that they are parallel. Step 1 complete. Now we want to compare the lengths of KL and GJ. Alright, so now let's look at the distance for KL and the distance for GJ. So we have KL, and that one's going to equal the square root of negative 2 minus negative 6 squared plus 4 minus 2 squared. And when we simplify, we end up with 2 square roots of 5. And now let's look at GJ. So it's going to be the square root of 1 minus negative 7 squared plus 2 minus negative 2 squared. And when we simplify this one, we end up with 4 square roots of 5, which is 2 times the size of KL. So therefore, we've met our second condition. Let's look at the triangle midsegment theorem. A midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. That's what we were just looking at. Now we have a theorem to go with it. So DE is going to be parallel to AC, and therefore we end up with DE being half the length of AC. It's really important to make sure you're playing with the ones that are parallel. So don't accidentally grab side DE and then like AB. They have to be the two sides that are parallel. And the two sides that are parallel, the smaller one, or the midsegment, will be half the length of the large one, which is the edge of the triangle, in this case AC. So let's put this to some practice. Find each measure. So we want UW. All right, well, let's look at which ones are parallel. So we have UW, and that one is parallel to ST. So therefore, UW is going to be half the length of ST. So it's going to equal half of 7.4, which is 3.7. Okay, well now we want to find the measure of angle SVU. So SVU. We're looking for the measure of this angle right here. Well, if we know that these two lines are parallel and that this angle is 41 degrees, we can use alternate interior angles and see that the measure of angle SVU is also 41 degrees. Once again, as soon as you see triangles and then parallel lines, you want to start looking for corresponding angles and alternate interior angles because it will provide you with more information. Try this next one on your own. Now that you've had a chance to try this one on your own, let's try it together. So we're looking for JL. JL, so that whole length. So we'll highlight that. Alright, so since PN is 36, and that one is the side that is parallel to JL, PN is the half size of JL, so we're just going to double 36 and get 72. Let's look at PM. Alright, so we have PM. We're going to highlight that in a different color here. We'll go with pink. And we know that PM has to be half the length of LK, because remember, we're always dealing with the ones that are parallel. So since PM has to be half of LK, that must be 48.5. Be careful not to think that PM and PN are the same length. Always deal with the ones that are parallel. It may help to highlight. Alright, let's look at our angle. We have the measure of angle MLK. So MLK. Okay, well, since LK and PM are parallel, we can think of JL as our transversal, and since JMP is 102 degrees, MLK must also be 102 degrees, and for this one we end up using corresponding angles. And that will end our lesson on the triangle midsegment theorem.